Yeah, she now rockin' with Mr. Wit. A little flavor from Q Beats, you know that this a hit. Michael Jackson bad, yeah, this is it. A few months ago I was about to call it quits, until I came across personalized math tutoring. FBT, the #1 solution. So what you waiting on? Everything is online.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is about rational inequalities. We're going to dig right into this lesson, starting out with problem number 1. Well, bottom line, when you have a rational inequality, you're talking about having rational expressions within an inequality. So in problem number 1, you'll notice that we have a rational expression, aka a fraction, greater than 0. So this is exactly the setup that you're looking for. You're looking for one fraction set to 0. That's what you need, okay? So in this situation, we have an ideal scenario. We have our fraction, it's greater than 0, and the next thing you'll need to do is find out what your critical values are. In order to find your critical values, you'll be setting the numerator and the denominator equal to 0. I'll have x minus 1 equal to 0, and I'll also have x minus 4 not equal to 0. The reason why you set your x minus 4 not equal to 0 is because the denominator can't equal to 0. It'll be undefined. It's an undefined scenario. So if you're looking for domain restrictions as far as this is concerned, your denominator cannot equal to 0 because it would make it undefined. Therefore, we're going to go ahead and add 1 to both sides of the equal sign in this first equation to find out our first critical value is 1. I'll add 4 to both sides of the not equal to sign, and I'll end up with x cannot equal to 4. I'm finding out two things about this value right here. One, I found out that the domain can never equal to positive 4 because it will make it undefined, and I'm also finding a critical value. So it's a 2-for-1 deal when you set your denominator not equal to 0. Alright, so once I have my two critical values in this case, I'm going to create a sign chart. Alright, so let me show you what my sign chart looks like. It's basically going to look like this, a number line with my critical values on it, 1 and 4, and the two factors that I have from my original inequality. I had a factor of x minus 1, and I also have a factor of x minus 4. I know that at 1 on my number line, this first factor will give me a value of 0. I also know that at 4, the second factor will make the inequality undefined. So remember, having 0 in the denominator of our inequality is not a good thing. It makes it an undefined situation here. So the next thing you'll need is a test value, all right? And I'm going to use a value smaller than my lowest critical value. So my smallest critical value in our problem here is 1, so I'll use a value of 0. And I'm going to plug this test value into each of my factors here to find out what the signs will be. All right, just concerned about the sign, not the actual value. So plugging in 0 into our first factor here, 0 minus 1 gives me a negative value. So I'm going to put negative signs here until I get to 0, and then after that, the sign will become positive. All right. Now, it's not going to always become positive after you hit that 0, but in most cases it will. So you can always check to verify the sign of the result. For instance, I can use a positive 3 into this first factor and verify that 3 minus 1 would give me a positive 2 or a positive value after I hit that 0. All right. So then in the second factor, plugging in my test value of 0, 0 minus 4 is a negative value. So I'm going to have negative results until I hit this undefined mark here, and then after that, I'll have positive results. Now, in order to utilize this properly, this is what we'll do. We'll look at our original inequality and notice that the answers must be greater than 0, which means we're looking for positive results. Here, I'm dividing. Remember, every fraction is a division problem. So I'm looking for these two factors to divide to give me a positive result. So let's see what that looks like on our sign chart here. A negative divided by a negative is a positive result. A positive divided by a negative gives me a negative result. And then finally, a positive divided by a positive is a positive result. So that means that on my number line here, we'll have positive results from negative infinity up to 1, not including 1, because our original inequality says that the solutions must be greater than 0, not equal to 0. So that's why you'll use parentheses here. You'll also have a positive result in this region from 4 to positive infinity. So not including 4, we'll have it shaded to the right so that it approaches positive infinity. In interval notation, your solution will look like this. You'll have negative infinity to positive 1 union 4 to positive infinity, and that's our answer, and I'm going to put a red box around it. All right, so in interval notation, your solution for this problem is negative infinity to 1 union 4 to positive infinity, and there you have it for problem number 1, ladies and gentlemen. Let's look at our next problem. So it's already set to 0, which is what we want, and the next thing we'll need to do is find out our critical values. So checking out the first factor, the numerator, I'll have 2x minus 3 equal to 0. And I know that the denominator x squared plus 1 cannot equal to 0. So in solving for the first factor, I'll need to add 3 to both sides of the equal sign. This gives me 2x, which is equal to 3, and then I'll be dividing both sides by 2. So x equals to 3 halves. Next, I'll be solving the second equation. I have negative 1 to both sides of the equal sign. This gives me x squared cannot equal to negative 1. Now, I'm going to stop right here, ladies and gentlemen, because if I try to take the square root of both sides, you'll end up with an imaginary value. In other words, you can't take the square root of a negative 1 and get a real result, which is what I need for my sign chart. And going any further, it would involve imaginary numbers, complex numbers. So that's not going to do us any good for this problem. So that means that our only critical value is going to be 3 halves. That's it. And I won't need any values from this second equation because they're undefined or imaginary at best. So therefore, let's go ahead and set up our sign chart. So my sign chart will look like this. I'm going to have my number line, and on this number line I'll just have my one critical value of 3 halves. I know I have 2 factors involved in the original problem. I have 2x minus 3, and I also have x squared plus 1. I know at 3 halves I'm going to end up with 0 in this first factor. And then there is nowhere on the number line where our second factor will ever be 0. Okay? In other words, you can't generate a 0 from this factor here. It's going to always be a positive result. Any number that I plug in here, I'm going to need to square it first, which takes care of the negative sign, and then I'm going to add 1 to it. So no matter what, all of these results for the second factor will have to be positive. But we'll go ahead and show that we'll need a test value. For our test value, I'm going to use 0. So plugging in 0 into the first factor, you'll end up with negative 3. That'll be a negative value. So I know I'll have negative values until I hit 0, and then after that, the results will be positive. All right, so it looks just like that. Then for the second factor, no matter what I plug in, it's going to be positive, but let's go ahead and see what happens. Plugging in 0, that's just going to be 0 squared, which is 0. 0 plus 1 is positive, so I have positive results, and I'm going to continue to get positive results no matter what I plug in. Remember, in our original inequality, we want our values to be greater than or equal to 0. So that means that anywhere we have 0 on our sign chart or where the result will be positive is a good thing. These are the solutions we're looking for. Notice that since we're dividing those 2 factors, a negative divided by a positive is going to be a negative result. Here, a positive divided by a positive is always a positive result. So my solution for this problem, including 3 halves, is going to be 3 halves to positive infinity, because this is the area where I end up with positive results, and it's at 3 halves that I end up with a value of 0 for my solution. So that's the result here. In interval notation, I will have a bracket, 3 halves, and then I'm going to positive infinity. That's ugly. That's ugly infinity. Let me see. Okay, that's a little better. All right, so this is the interval notation for your result. I'm going to put a box around this. Yes, it's red. Okay, so that's it for problem number 2. Okay, good stuff. Good stuff. Let's move on to the next problem. Here we have problem number 3. It's a good problem, by the way. And we have 6 divided by x minus 1 is less than 1. Recall that the ideal scenario for your inequalities is that you end up with one fraction and that fraction is set to 0 in your inequality. Well, here we have it less than 1. Well, I need it to be less than 0. So that means I'll be starting out by subtracting 1 to both sides of the inequality here. So this is my first step. I'll end up with 6 over x minus 1 minus 1 being less than 0. All right, so one of the 2 conditions has already been met. But the second condition of me having one fraction has not been met yet. So that means I'm going to combine these 2 numbers. So I end up rewriting this as 6 over x minus 1, and I'm going to rewrite 1 as this denominator over itself. So this is going to be minus x minus 1 over x minus 1, which is less than 0. From here, I'll be combining my numerators. This will be 6 minus the quantity of x minus 1 all over the denominator of x minus 1, which is less than 0. From here, you'll be distributing this negative here. So I'm going to get my arrows popping to show you that this negative will affect both terms in that numerator there, or both terms in this set of parentheses. So you'll rewrite it as 6 minus x plus 1 is going to be divided by x minus 1, which is still less than 0. So finally, from here, you end up with a result that is negative x plus 7 all over x minus 1, which is less than 0. Now that I have the inequalities set to 0 and we can identify the factors in the numerator and the denominator, we're going to find out our critical values next. So I'll have negative x plus 7 equal to 0, and my denominator x minus 1 not equal to 0. So we'll be subtracting 7 to both sides of the equal sign. This gives me negative x equals to negative 7, and then I'll be dividing both sides by negative 1 to end up with x equals to positive 7. Then, with the second factor, I'm going to be adding 1 to both sides to find out that the value of x cannot equal to positive 1, or it'll be undefined. So my critical values are 7 and 1. Let's identify those. There we go, and there you go. These are your critical values. So next, I'll be coming up with my sign chart here, okay? So with my sign chart, I have my number line and my two factors, negative x plus 7, as well as x minus 1. On my number line, I know I have a critical value of 1, and at 7, I know that at positive 1, my second factor will be undefined, and I know that at positive 7, my first factor will equal to 0. Then I'm going to use a test value, all right, and let's say that we use 0 for our test values. As long as your test value is less than your lowest critical value, you're fine. So I'm choosing 0 here because it's easy to plug in. Plugging in 0 into the first factor, I'll have negative 0, or just 0 plus 7, so that gives me a positive result till I get to 7, and then it becomes negative after that. Plugging in 0 into your second factor, you'll have a negative result until you get to that undefined spot, and then those values will be positive. All right. Looking back at our inequality here, notice that these two factors need to divide to get a negative result because the results should be less than 0. All right. So here, taking a look at your sign chart, a positive divided by a negative is a negative result. A positive divided by a positive is a positive result, and a negative divided by a positive result is a negative result. Remember, we want the results to be negative. So therefore, I have a negative region here from negative infinity all the way to 1, not including 1 because that 1 makes it undefined, remember? Then, from 7 to positive infinity, I'll have a negative region here. So that's my answer. If I were to write my result in interval notation, it would be like this. I would have negative infinity to 1 union 7 to positive infinity, and this is going to be the answer to problem number 3. Let's take a red box around that, shall we? All right, here you go. That's my result, ladies and gentlemen. Let's keep it moving. All right, in problem number 4, we have the following problem. We have x minus 2 divided by x plus 2, which is less than or equal to positive 2. Remember, you want to set your inequality to 0. So we're going to start by subtracting 2 to both sides of the inequality here. This leaves me with x minus 2 divided by x plus 2 minus 2, which is less than or equal to 0. So my first step is getting it equal to 0, and it is, okay? So set your inequality to 0. Next, you want to end up with one fraction. So in order to do that, I need to get a common denominator. So I have x minus 2 over x plus 2 minus 2 times x plus 2 over that denominator of x plus 2. In order to get a denominator of x plus 2 and make it an equivalent fraction, I had to multiply the numerator and the denominator by x plus 2. Now, this is still less than or equal to 0, and now I can combine my numerators together. This gives me x minus 2 times the x plus 2 here, all over that common denominator of x plus 2, which is less than or equal to 0. I'm going to then distribute that negative 2. So I'm about to get my arrows popping, so I'm really excited about that. I'm going to circle that negative 2, get my arrows popping up in here, and then I'll be able to rewrite this as x minus 2 minus 2x minus 4 all over that denominator of x plus 2, which is less than or equal to 0. Combining my like terms in the numerator, I'll end up with the following result. I'll have negative x minus 6 divided by x plus 2, which is less than or equal to 0. And this is the ideal form of your inequality, ladies and gentlemen. Once I have the inequality in this form, I want to go ahead and find out my critical values. So I'll set negative x minus 6 equal to 0, and I'll be setting x plus 2 not equal to 0. Then solving for x in each of the equations, I'm adding 6 to both sides of the equal sign here. And this is going to give me negative x equal to 6, which I'll divide both sides by negative 1 to end up with x equaling to negative 6 here. So that's my first critical value, negative 6. Then I'll be subtracting 2 to both sides. So x cannot equal to negative 2, and negative 2 is also another critical value. So I'll be circling those. All right, so that you'll see that my critical values are negative 6 and negative 2. Next, I'll be placing this in a sign chart. So I have two critical values. The first one is negative 6. The second one is negative 2. And I know I have two factors. One is going to be negative x minus 6. The other factor is going to be x plus 2. At negative 6, my first factor will equal to 0. At negative 2, my second factor will be undefined because it's in the denominator. Then I'll be choosing a test value. And the test value I'll pick here is negative 8. So just as long as that value is less than my smallest critical value, it's good to go. So let's plug that into the first factor. Negative 8 plugged into this first factor here, that makes it a positive 8. A positive 8 minus 6 gives me a positive 2. I'll end up with positive results until I hit 0. And then after that, those values will be negative. Then, plugging in negative 8 into the second factor, I'll have negative results until I hit this undefined mark, and then the results will be positive. Looking back at my inequality, my solutions must be less than 0 or equal to 0. So I'm looking for negative results or 0. So here on my sign chart, I know that a positive divided by a negative is a negative. I know that a negative divided by a negative is a positive result, and a negative divided by a positive is a negative result. So that means that my solution will be found from negative infinity to negative 6, including negative 6, because it can equal to 0, and it'll be from negative 2, not including negative 2, to positive infinity. The reason why you're not including negative 2 is because it makes the original inequality undefined. So in interval notation, it will look just like this, ladies and gentlemen. You'll have a result that reads negative infinity to negative 6 bracket union negative 2 to positive infinity. All right. And that's your result right there, ladies and gentlemen, in interval notation. So let's get a box around that answer here. All right. That's the result. Negative infinity to negative 6 bracket union negative 2 with parentheses because we're not including negative 2 to positive infinity. And that's the answer to problem number 4. Let's check out our last problem. Problem number 5, ladies and gentlemen. We have x squared minus 9 divided by 2x minus 1 less than or equal to 0. So what I want to do here is recognize that I do have one fraction. It is set to 0, but I can factor the numerator, ladies and gentlemen. So that's what you want to do. So I'll end up with x plus 3 times x minus 3, recognizing that the numerator is a difference of squares. All right, so if you need any practice on factoring a difference of two squares, check out our video, Factoring Difference of Squares. All right, I got a link right down there. Then you're going to set each one of your factors that you see here equal to 0 to find out your critical values. So I'll have x plus 3 equal to 0. I'll have x minus 3 equal to 0, and I'll also have 2x minus 1 not equal to 0, because that will make it undefined if it ever is 0. From there, you're going to be solving for each one of your critical values here. So I'm going to subtract 3 to both sides. This gives me x equals to negative 3. I'll be adding 3 to both sides of this equal sign here in the second equation to get x equals to positive 3. I'll be adding 1 to both sides of the equal sign. I'll end up with 2x cannot equal to 1, and then I'll be dividing both sides by 2 to find out that x cannot equal to 1/2. And so my critical values are going to be negative 3, 3, and 1/2, just like that. Now I'll be coming up with my sign chart for my result. So looking at my sign chart, I'll have my number line. On it, I'll have my 3 critical values, negative 3, 1/2, and positive 3. I'll also need to have a test value. So I'm going to use -4 as my test value. And of course, I'll have my factors. I'll have x plus 3, x minus 3, as well as 2x minus 1. I know that at -3, my first factor is going to be 0. I know that at 1/2, my last factor here will be undefined. And I know that at +3, my second factor will be 0. What I need to know now is going to be the signs that I generate from this test value, plugging it into my factors. So -4 going into the first factor, I'll end up with a negative result until I get to 0, and then after that the values will become positive, like so. Then plugging in -4 into the second factor, I'll have negative results until I get to 0, and then the results will be positive. All right. Plugging in -4 into the last factor, I'll end up with negative results until I get to that undefined mark, and then those results will become positive. All right. Remember that at our factored form of our inequality, that we're looking for values that are less than 0, in other words, negative numbers, as well as 0 itself. So let's see how that works out on our sign chart here. All right. I know that a negative times a negative divided by a negative will give me a negative result. I know that a positive times a negative is negative, and then a negative divided by a negative will give me a positive result. Then here I have a positive times a negative, that's negative, and then a negative divided by a positive is a negative result, and then finally a positive times a positive is positive, then divided by a positive result will give you a positive result here. All right, so that area here is positive. So ladies and gentlemen, remember we're looking for negative results and 0. So my negative results will be at -3 to -infinity, or -infinity to -3, including -3, and I'll also have negative results between 1/2, not including 1/2, and 3, including 3, because 3 generates a 0, and that's one of the solutions I need. So my solution in interval notation will be -infinity to -3, including -3, union 1/2 to +3. All right, and make sure you have a bracket to include 3 in your solution. So this is it, ladies and gentlemen. This concludes problem number 5, as well as this video on solving rational inequalities, ladies and gentlemen. Once again, this is Mr. Witt with Fort Bend Tutoring. Please rate, comment, and subscribe. Please subscribe. And if you're able, please donate. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry. Pre-cal calculus, can't forget trigonometry.